Okay, let's go ahead and get started. So just so that we know what this week looks like, today we're going to do a review of what is going to be on the chapter test. Tomorrow we're going to have a day to work on the review. I'll just let you know right now though, tomorrow is optional. So if this matrix stuff has been easy for you, tuning in tomorrow to do the workshop review session, or I'm sorry, I'll put it this way, sticking around for the review session is up to you. So tomorrow you have to sign on, you have to do the warm-up. But after that, if you're like cool with this stuff, if you're confident about the chapter test on Wednesday, then you can just head out after the warm-up. And then we'll have the chapter test itself on Wednesday. Today we'll talk about what's on it. Today I'm going to put out the review assignment itself. And a good half of the questions will be built so that you have to do it by hand, because as we've gone along, I've been really clear with you about how to use your graphing calculator to get these answers for numeric solutions. And so to make sure that everybody is on an equal playing field, about half of the questions will be built out like the ones in today's warm-up, where you'll notice that not all of the entries are values. So if you figured out how to use your graphing calculator to do these operations the way that I've shown you, or we all are sitting right now at some sort of computer to listen to this lesson, which of course, that computer can be used to do these things trivially. I'm going to be really clear in some of the instructions about showing all of your work and doing the work by hand, proving to me that you can do it. Because on the last test, there were a good number of people who had the correct answer, but either no supporting work or, my favorite, the wrong supporting work. And you should know that that doesn't fly, even if these tests are take-home, which is why even though there were a few of y'all who may have had all of the correct answers by the end, you didn't get a perfect score, because I'm still grading the work, not just the final line. So this is a good look at a question that I can write that makes it so that you can't just use a calculator, simply because calculators will typically only take digits. So item number 1, multiply these two matrices, reverse the order, and then multiply again. Since some of the entries are variables, that means that you will have to do this by hand. And then same thing here, item number 2, take the determinant of matrix C by any method. You can use either the shortcut that we looked at last week on Friday, or you can use the formal definition, which is actually pretty easy because there's a couple zeros here. When I do it, I'm going to use the formal definition, but know that if you're going to use the shortcut, you end up getting the exact same answer. Yeah, after that, I'll go through section by section and tell you what's on the test. I mentioned this at some point in the middle of the second half of this chapter, but the first half of the chapter is not on the test. It's going to be about the matrix stuff only, so that I can just test that. And then after this chapter test is over, we'll go over it on probably Friday. It'll probably take me a couple days to grade. But you should also know, just kind of mentally for your own planning, the next chapter that we're getting into this is going to be the last chapter of the class, the last one that will have associated tests and quizzes with it. After this, the next thing that we're going to do is chapter 11, which is fundamental statistics, which is like one of the last big pillars of math that you may have looked at some of the topics within statistics, but it's considered like one of the pillars of math, like separate and apart. Up until now, all of the math that you have learned is just progressively more difficult algebra. But honestly, all of the math that you have command of right now is algebra or geometry, right? You still have yet to learn the last two components of mathematics aside from those two, which are, everything uses a little bit of algebra, but these ideas are considered to be independent. You have algebra, you have geometry, you have calculus, and you have statistics. Next year, y'all will go on to learn calculus, ideally either in your senior year of high school or whatever your first year of college looks like. But what we're going to be looking at in chapter 11 is statistics, the basics of it, counting theory, counting techniques. And just so y'all know, statistics is particularly important for those of you headed into biology or medicine. That is probably the math that is worth understanding most if you're headed towards one of those biological fields. Anyway, like I said, take a few minutes on today's warm-up, then we'll go over it together, and then we'll do a breakdown of exactly how many and what types of questions will appear on Wednesday's test. And then I'll put out the assignment, and you can work on that for whatever time is left of this period. And I'll also be taking just questions tomorrow after the warm-up. Tomorrow's warm-up will be short so that it can just be time for questions and answers if you have any out there. Let me take attendance, and then we'll get started. How's it going out there?
It's all right.
Yeah. Just fine.
Well, Mr. Robinson, I forgot to turn in my do not from last week.
Oh yeah, I forgot to remind anybody. So yeah, I mean, I don't mark those late anyway, but yeah, last week at the end of the day, I didn't remember to post the classwork assignment until a kid in geometry asked. If you didn't upload last week's classwork, please do so under week 5 classwork. And of course, you know, it's not late. I would never mark this late, even if it was in person or whatever.
Okay, thank you.
Oh yeah, and I don't know where the time came from exactly, but we're actually a little bit ahead of schedule. Let me tell you exactly how much and what I'm gonna do with the time. So 1, 2, 3, 4. Yeah, so we have 4 weeks left to finish 1 chapter. The chapter will probably only take us that top set of 3 weeks. So for that final week, what we're gonna do is, for the first time ever, I'm actually gonna make it all the way to the final chapter of this book, which is Introduction to Calculus. This is something that you'll get fleshed out in a ton of detail next year, but calculus is made of 3 ideas primarily. It's made of limits, derivatives, and integrals, where derivatives and integrals are 2 different skills, 2 different ideas, but both of them are proven by the idea of limits. So the last chapter of this book in Precalculus is actually an introduction to calculus itself. So it's really just limits, just that first idea, which is a really gnarly idea. It basically makes it so that, you know how all the way up until now, divide by 0 for us means what? What do we talk about when we have a case where we would divide by 0?
Undefined.
Yeah, we just say it's undefined and then we don't touch it. But just like how when y'all were babies in middle school, you were told that if you take the square root of a negative, you just don't do that. It's just no solution, because if you take the square root of a negative number when you're solving for the roots of a quadratic, it means the quadratic doesn't have roots, blah, 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 blah. But now that you're older and smarter, what does it mean when you take the square root of a negative?
It's unreal.
Yeah,
It's a complex number.
not that it's unreal, it's imaginary, right? And that it's a
Yeah,
complex number with one part real, one part imaginary. And so the smarter you get, you've learned that we actually have more elegant, more complicated structures to capture these things that we can't do with normal number sets. The same is true of dividing by 0, and that itself is resolved by limits. So that last week of school, before finals, right after Memorial Day, it'll be like the Memorial Day Tuesday to Monday, we'll be done with the last chapter, and I will have given out the final review packet or whatever. But in those days, we'll be doing the very first lectures of calculus. Just because, you know, you'll find yourself there either over the summer if you're hardcore and you're going to do summer school to get ready for community, or if, you know, you'll be taking that stuff in the fall. Trust me, it'll make it a lot easier if you see it once before you are graded on it. I'm only saying this now so that you know that when we get there, that calculus topic, the idea of the limit, we will talk about it and we'll have a homework assignment about it, but at no point will we be quizzed or tested on it, and it won't appear on the final. Okay, I think that's it in terms of announcements for this whole week. So let's go ahead and get started. Item number 1, we're being asked to multiply these two matrices, and just a reminder, this is a look at these questions on the test. Some of them will have numbers and I'll ask you to do them regular. Some of them will have variables plugged into them in at least one entry, just so that a calculator itself is not helpful. So how do we do this? What's the dimension of our first matrix here? What's his size?
3 by 3. 3 by 2.
Oh, sorry. 3 by 2.
So this first one is a 2 by 3 or a 3 by 2. Which one is it?
3 by 2.
This is a 3 by 2 because it's rows by columns, right? Always rows first. And then over here, what's the dimensions of this guy?
2 by 3.
That's a 2 by 3. And the inside numbers are the same. This is 2, this is 2. And that means that our outcome is going to be what size?
2 by 3.
Sorry, what's the size of
No,
our
3 by
final
3.
matrix?
3 by 3.
3 by 3.
Our final matrix in the end here is going to be a 3 by 3. And again, I'm going to use the highlighters, even though I know it's silly, especially this late into the chapter. But whenever I look at matrices, when I'm doing this stuff in my brain will just fill in those lines so that I don't get lost. And so for 1, 1, we're going to do row 1 by column 1, which is going to be a times a, which is a squared, plus b times 0, which is 0. So this first entry is a squared. And I'm going to go through and I'm going to do the same thing for the rest of these entries. I'm going to try and keep it neat. So it'll be row by column for that next entry. So it's going to be AB plus 3B. If you would like to be fancy in that entry, you can factor out the B and get B times A plus 3. And then in the final entry here, it's going to be A times 0 plus B times C, which is BC. And then we'll keep trucking right along. So row by column. That one's just 0 because it's going to be 0 times A plus D times 0. Middle entry here, it's going to be 0 times B plus D times 3, so 3D. 0 times 0 plus D times C, which is DC. And then final entry, it's going to be E times A, which is EA, plus 0, because it's 0 times 0. E times B plus 3 times 0, EB. And then E times 0 plus 0 times C, which is 0. So right there is our first product. Are there any questions there in item 1, or did I make a mistake? No? Okay.
That looks.
Now let's go ahead and reverse the order and multiply again. And are we going to get the same answer?
No.
Heck no. And not only are we not going to get the same answer, but the answers to these two steps will look very different. Why?
It's gonna be a 2 by 2.
Very good. So this is A, B, O, 0, 3, C. A, B, 0, D, E, 0. And this is why we don't really use the letter O as a variable, because it gets confusing. Of course, the test will be typed up, so it'll be very clear. I'm sorry if anybody thought that that was the letter O, but I'm not a savage. I would never use the letter O as a variable. Nonetheless, yeah, so the second one is going to be different because rows by columns. This first one is a 2 by 3. This one is a 3 by 2. The 3s are the same dimensionality, which means that we are allowed to do this operation. But in this case, the surviving digits on the outside indices, those are 2s. So our answer is going to be a 2 by 2. So we'll go ahead and get into the production of this answer. So it'll be A times A plus B times 0 plus 0 times E. This first entry is just going to be A squared. And then the second entry is going to be A times B plus B times D plus 0 times 0, which is just 0. And again, if you were feeling fancy, you could factor out the B and say that this is B times A plus D, but that's overkill. And now for the bottom row, it's going to be 0 times A, which is 0, plus 3 times 0, which is 0, plus CE. And then the bottom right entry is going to be 0 times B, which is 0, 3 times D, which is 3D, and then C times 0, which is 0. Notice, just by inserting a couple zeros in here, it makes it so that these final answers end up a little simpler than you would think, kind of clean almost. And again, you can expect that on the test and on basically any exam about matrices. We always put zeros in there so that it's not the maximum amount of computation that it could be, you know. If there were no zeros here, then both of these would be made of 3 elements each. Because of those zeros, it makes it so that something this simple can be the answer. Are there any questions there?
No, looks
Okay. Okay. Item number 2, we're asked to take the determinant of this matrix C, which again has some undefined variables plugged into it, so that, you know, our graphing calculator can't just give us the answer, but instead we'll have to show some work. Like I said, I'm going to do mine by going across to the top row using the method of minors and cofactors, though you are free to use the shortcut when it comes to using or finding the determinant of a 3 by 3. In the end, the answers are going to be exactly the same, even in this case where these are variables, undefined variables. So in the determination of my determinant, I'm going to use row 1. And not because you have to use row 1, it's just that, you know, that's how I showed you how to do it in the notes. But on top of that, there's a side benefit of using row 1 here. What's that side benefit?
there's a 0.
There's a 0.
Yep, precisely. So that is to say that it's going to be equal to 0 multiplied by the determinant, right? And again, since today is a review day, what's this 0 called in terms of the vocab that we learned this section, or this chapter?
A minor? No, cofactor.
There we go.
Cofactor.
That one's a cofactor. And then this other determinant of a little matrix that we're going to multiply it by, that's the minor.
Minor.
And we like zeros because as soon as you realize that your cofactor is 0, there's no point in figuring out what that minor is, right? Like I could write that this is C negative 1, 3, 0, but who cares? Because 0 times anything is going to give us back 0. If it's up to you and you're taking the determinant of some large matrix, like a 4 by 4, if one of those rows has a bunch of zeros in it, that is the row that you want. Okay. So we have to go all the way across the row to get the determinant. This first entry is 0. So I'm going to ignore whatever is in here. We don't care. But this is going to be +2 or -2?
-2.
minus 2. Keep in mind our checkerboard of signs. So if this is what we're dealing with, it's plus, minus, et cetera, et cetera, et cetera. And you have to tag the plus or the minus onto that cofactor. So it's going to be negative 2 multiplied by the determinant of the minor matrix. The minor matrix is what you get when you block out the column that that number is in and the row that it's in. And so the minor matrix here that we're taking the determinant of is 7 minus 1, A, 0. And then our final cofactor and minor set that we need to produce this determinant is just this one here, D. So it's going to be plus D multiplied by the determinant of the minor matrix made when we block out its row and column. On the smartboard, when I do this lesson, I usually just draw like a red rectangle of each size and then slide them around on the, you can imagine this, right? Anyway, 7CA3, okay? And so these are the 3 pieces of information that we need in order to calculate our determinant. So this first part is just going to give us 0 because the cofactor is 0, minus 2 times what? How do I do the determinant of a 2 by 2?
You multiply A and B and
Multiply
you switch
diagonally.
B and C.
Multiply
you switch the-
diagonally and then subtract and multiply diagonally. So this first one is going to be minus 2 times, well, 7 times 0, that's going to be 0. Minus negative 1 times A, which is going to be minus negative A. The negative and the negative will cancel, giving us a plus A. And then finally down here we get D, so this is going to be plus D multiplied by the determinant of this 2 by 2, 7 times 3 minus AC. So it's going to be 21 minus AC. And so the determinant of C is going to be equal to negative 2A plus 21D minus DAC. And even if you do this by the shortcut, you should get something which is mathematically equivalent. Though your terms may be in a different order or whatever, they should all have the same value. Is this okay? Are there any questions of the finding of this particular determinant?
No, this looks good.
Okay. And just be forewarned, it won't be all of the questions because I do want you to be able to use your calculator to guarantee some of the solutions. But about 1/2 of the questions will be like this, where they will be these things that we've done, these operations, but with a few undefined variables plugged in. Just know that in any question with an undefined variable, those undefined variables appear in the answer. And so here's what is on Wednesday's chapter test. It'll be, class time. I expect everybody to log in on Zoom so that if you have questions during the test, you can ask them. And the first important part about Wednesday's chapter test is, yeah, just that announcement that some questions will have undefined variables. So calculators can't help. These questions must have those same undefined variables in the solution. I only say that out loud because I get lots of students in lots of classes where they will have some sort of question that is supposed to have variables in it, but just because they can't solve them, they just don't write them in the answer. Like, let's pretend the answer matrix is supposed to be A, B, 1, 3. I have lots of students who will just write 0, 0, 1, 3 because they assume that the answer can't have variables in it, because if you didn't pay attention to what was actually going on in Algebra 1, you think that that's how math works, that answers always have to be numbers. I'm saying this clearly because if a question has undefined variables in the matrices in the question, The answer matrix will have those same undefined variables in it. Oh, other thing is there will be no content from 9.1 through 9.4. Not really. And this is for two reasons. Number one, 9.1 through 9.4 was before spring break, right? So it feels like a million years ago because it kind of is. And I would argue that the only thing that we're missing out on from 9.1 through 9.4 is actually section 4, partial fraction decomposition, because other than that part, right, the rest of this whole chapter has been about solving linear equations. And the big takeaway from section 9.6, solving systems with Gaussian elimination, was the fact that all of those linear systems that we solved in the first half can also be solved by these different matrix methods, right? And so I would argue that even though this math looks different in terms of content, it's the same stuff as the first half. We're still testing on that stuff. It's just that I'm not going to give you any questions that are from the first half of this chapter only. I'm not going to ask you to do partial fraction decomposition. I'm not going to ask you to graph inequalities. And I'm not going to ask you to solve a system of equations explicitly by substitution. Are there any questions about what is being excluded from the first half of the chapter? No? Okay. So then here's what will be on the test chapter by chapter. And then after I go through and I write out the skills, I'll tell you how many of each. Yeah. So section 9.5. This part was pretty straightforward. This was matrices, and operations. This was where we basically just had like our intro to matrices. There was really very little here. And so here are the takeaways that you want to have from the basic introduction section to matrices and operations. We want to have definitions, which is to say rows, columns, what those mean, how they're applied, why that information might be useful to us, but also identification of individual entries as being A1, 1, or A1, 2, or whatever, right? The names of individual entries within a matrix where that first digit is the row and that second digit is the column. We also want to know that we can add, subtract, multiply, and divide. We can add, we can subtract, and we can do scalar multiplication. However, division itself is not well defined. The closest thing that we have to matrix division is the use of an inverse matrix, which we'll talk about later. And then past that, we also have matrix multiplication that we need to be able to do. And so when it comes to addition and subtraction, I think those are pretty straightforward. What's the big rule that we have to observe when it comes to matrix addition and subtraction?
They have to have the exact same dimension.
They have to be the exact same size, otherwise there's no operation. And then scalar multiplication is also pretty straightforward. If you take a matrix and you multiply it by a number, you multiply every value in that matrix by that exact same number. When it comes to matrix multiplication, we laid down this definition in the warm-up. We said that if I take some matrix which has dimensions A times B, and I take some other matrix which has dimensions of B times C, matrix multiplication in this case is allowed because these middle digits are identical. If these two middle digits are identical, there is no product. And that gives us a final matrix of dimensionality A by C. I want to go ahead and give everybody the red flag that I'm going to ask more questions of this type than are possible. And that is going to be true of addition and subtraction. Not all of the ones that I ask will be possible. And when it comes to matrix multiplication, not all of the ones that I ask will be possible because I need you to know how to check for this property. And so there will be no solutions mixed in. It is possible to get no solution for addition, subtraction, and matrix multiplication, though technically scalar multiplication is always doable. That's fine. Okay. From 9.6, this is where we get into solving by Gaussian elimination. And when it comes to solving by Gaussian elimination, there's really just two parts here. Number one, you need to know how to turn a system of linear equations into an augmented matrix. So if I give you the linear system of 3x plus 4y is equal to 12, 6x minus 2y is equal to 11, you need to be able to know how to pull those coefficients off and build them into a matrix, which can then be solved. And then after you have it turned into this augmented matrix, you use valid row operations until the left-hand side of the matrix is the identity matrix, at which point the right-hand side of your matrix is now the solution. When it comes to using valid row operations until the left-hand side is the identity matrix, we have three valid row operations. Row operation 1, we can multiply a row by a scalar. And the goal there is so that we can line up two entries to eliminate, right? If I have -2 in one of my x columns and my other x value is 1, we're going to multiply that row with 1 by +2 so that -2 and +2 can eliminate and one of those can be 0. The way that we eliminate them is by adding one row to another. And there's this third row operation that I mentioned once we got to inverses that might be useful to you depending on the nature of the question, though it's technically unnecessary. Oop, dropped my pen. Though it's technically unnecessary in solving these questions, the other thing that we can do is that we can swap rows. However, you play the game up until your matrix looks like the identity matrix on the left-hand side, and then your right-hand side has become the solution. I will not ask anything bigger than a 3x3 here. For this part, I will probably ask 1 or 2 2x2s at most, and at absolute most 1 3x3, just because this is time consuming. And like I said, the thing that I'll be grading is the work. Section 7.
Mr. Robinson, do you know how many questions are going to be on the chapter test?
I do, yeah. I'm going to go back and give the digits after I write out these notes, yeah.
Okay.
Okay, so 9.7, inverses, I'll just call it. It's technically called solving with inverses, but let's call it inverses. Anyway, when it comes to inverses, the inverse of a matrix is a second matrix which undoes what a matrix itself does. So there are two matrices, right? A and a inverse, and they have some nice properties. They have the nice property that A multiplied by A inverse is equal to A inverse multiplied by A. So this is our first interesting feature that they have. They are commutative, which typically matrix multiplication is not commutative. If you change the order of multiplication, you change the answer. In fact, we showed that in part 1 of the warm-up, right? That if you multiply those two matrices one way, you get a 3x3. If you multiply them the other way, you get a 2x2. Inverse matrices have this special relation with their inverse, where multiplication is commutative, but moreover, any way you multiply them, you get back the unit matrix I. Now, this has the nice feature that allows us to solve for This has a nice feature that we can use inverses to then solve for the solutions to a system of equations. Because let's say that we have our augmented matrix, A, right? And then we would multiply that by our variable column, which would be X, capital X, which would be, you know, X, Y, Z, or W, X, Y, Z if we were solving 4 equations or whatever. And then this is going to be equal to our constant matrix B. If I happen to know what the inverse of matrix A is, we can hit both sides of this equation with matrix A inverse, which would give me A inverse A multiplied by X is equal to A inverse B. And notice here on the left-hand side, A inverse times A, this will give me the unit matrix I. And what's the special property of the unit matrix? Anything multiplied by the unit matrix gives us back anything multiplied by the unit matrix gives us what? What's 4 times 1?
It gives itself
Gives
back.
you itself.
It gives you back that thing. That's what it means for something to be identitarian, is that if you multiply it by a thing, it's just going to give you back that thing. So I times X is actually just X is equal to A inverse times B. Which means that if you are solving a system of linear equations and you already have the inverse matrix on hand, that inverse matrix multiplied by the constants on the other side of the equation, this will immediately give you the answer to that system. So here's what I'll be asking you to do under the section of inverses. So I'm going to ask you to prove inverses. Which is this relationship right here. It's that 2 steps of calculation. So if I give you a matrix and its inverse, you need to be able to show that A inverse is equal to A inverse A is equal to the identity matrix I. And yes, that does involve 2 separate steps of matrix multiplication. You also need to know how to find an inverse. By construction. This is to say that you set up your inverse matrix by attaching it to the unit matrix. So I have A, and then we're going to attach it to the unit matrix I, and then we do a series of row operations until the left-hand side becomes the identity matrix, and now the right-hand side has become our inverse. And then the last thing that I'm going to tack on here about inverses, which technically comes from 9.8, but I'm going to put it here anyway, because I think it goes nicely here, is we actually have a shortcut for the inverse of a 2 by 2. Now, the reason why this doesn't come up until section 8 is that it uses a determinant, which we're going to get into for our recap of what skills are in 9.8. But just as a quick reminder, if A is equal to the following 4 entries, A, B, C, D, then the shortcut would tell us that A inverse is equal to 1 divided by something multiplied by, and how do we do the shortcut? How are we going to swap these moves around or move these pieces around?
Switch A and D and switch the signs of B and C.
DA, and then we're going to make the, so this diagonal gets swapped, this diagonal gets negative, so it's going to be negative B, negative C, and then what's down here is going to be AD minus BC. So if you have some 2 by 2 matrix, the inverse is this, and you can do that real quick by memorization. Now, the part that is the determinant is this denominator right here. That's actually the determinant of A. So the other way that we write this down is by saying det A in the denominator. And that takes us to our final section, which is 9.8. And then I'll go back through and enumerate the numbers and types of questions. 9.8 is all about determinants and Kramer's rule. So determinants and Kramer's rule. So that's stuff that I talked about in the first half of the notes for 9.8 about the character of a matrix, that a matrix determinant can give us the area of a triangle, the volume of a parallelepiped, blah, 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 blah. Those applications are obviously not on the test. We didn't even talk about them. I just wanted to give a little bit of motivation for why we even care about this stuff. But here's what's up in terms of like what I can put on the test for this section. The determinant of a 2 by 2 is the only one which is super well defined. So the determinant of a 2 by 2, A, B, C, D, just as a quick reminder, is this diagonal minus this diagonal. So this is equal to AD minus BC. The next thing that you'll need to know about these matrices is that if a matrix has a determinant of 0, then there are two important facts about that matrix that we have to appreciate. Any linear set of equations produced using matrix A has no solution. So it has no solution as a linear set. And the other important feature it has is it has a determinant of 0. It also has no inverse. If you take the determinant of a matrix and that determinant is 0, you literally cannot produce the inverse of that matrix. You can't do it by shortcut. You also couldn't do it by the formal construction either. For the determinant of a 3 by 3 or any bigger matrix, so for larger determinants, require our system of cofactors and minors. And I'm not going to notate that because we did that in the warm-up. You could look at the notes for that technique. It is long and difficult. The one main thing that I'm going to remind you about this system of cofactors and minors is that checkerboard of signs where the top left value is negative. This is important because if you get even one of these signs wrong, it will make your final answer for the determinant in that case wrong. But please keep in mind that that top left corner is positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. And I guess this would be in the specific case of a 4 by 4 or whatever size may be, but you have to multiply your cofactor by negatives for half of the entries. And then the two last things here. Number one, we have a shortcut for a 3 by 3. If you look at the notes, we have a nifty trick that we can use to quickly find the determinant of a 3 by 3 matrix, where we copy paste over columns 1 and 2, and then we take diagonal, 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 add those together, diagonal, 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 subtract those from that first 3 set of numbers, and then that will give you the determinant of a 3 by 3 very quickly. And then the last thing is actually Kramer's rule itself, which I'm not that into, where if you are solving a system of equations, let's say it's a 3 by 3 with x, y, and z, x is going to be equal to the determinant where we mess up that first column, we replace x with the right-hand column of constants, and then you divide that by the overall determinant. Y is going to be equal to the determinant where you replace the y column with that column of constants, and then divide by the overall determinant. And then z is going to be equal to the determinant where you replace the z column with the constants, and then divide by the overall determinant. So if you are doing this for a 3 by 3, solving the system of equations is actually going to cost you the calculation of 4 determinants. The determinant for the overall matrix, and then the determinant of this submatrix, and that submatrix. So now let me go ahead and go through and tell you how many of each question type will be on there, though I will not warn you which questions will have undefined variables. It could be anywhere. So from section 5, I'm going to ask 2 vocab questions right off the top. And not vocab like, hey, use this word correctly in a sentence. I'm going to display some matrices and ask you, like, how many rows? What is the value of entry 3, 2? Just be able to use that stuff. I'm going to ask some number of these, but like I said, not all solutions are possible. So I'm going to ask probably 3 of this right here, which will be possible. So there will be more than 3 posed, but know that you should get no solution for some of them. And then when it comes to just plain vanilla matrix multiplication, I'm only going to ask 2 of these, even though it's a big skill. And that's mostly because this skill comes up again in inverses, right? To verify that 2 matrices are inverses, you have to multiply them. When it comes to solving by Gaussian elimination, You need to be able to turn a system of equations into an augmented matrix. So that's just kind of by default. There will be one of those, and I'm going to ask you to transform it into that before you begin solving it. And then when it comes to solving these, I'm going to ask you to do this for 2 2x2s and 1 3x3. The 3x3 will have a couple zeros pre-installed in it so that it's not super time consuming. A couple of the necessary values will already be zeroed out so that you can get it done quickly. For 9.7 inverses, this is the part that I think is spicy. I'm going to ask you to prove that 2 things are inverses twice. I'm going to ask for 2 of those. I'm sorry. It will have 2 parts. It's one question. The sense in which it is 2 parts is that I'm going to ask you to do this, and then I'm going to ask you to do that. I'm going to also ask you to find an inverse by construction, and I'm going to ask you to do this for a single 2x2 and a single 3x3. And then down here, I'm going to ask you for the shortcut inverse of a 2x2. There will only be one of these. And after I have you do this, I will then have you prove it. So after I have you show that, or sorry, take the inverse by shortcut, I will then ask you to multiply it, and not both ways. I will give one of these 2 and ask you to do it to show that it multiplies and gives us back I. Is that okay?
Yep.
Okay. And then for this last part, determinants and Kramer's rule. So there will be a couple different questions where I ask you to find the determinant of a 2x2, and I might ask you a question about it, which means that for one of those, I will have this follow-up question, right? If the determinant is 0, it doesn't have a solution, and it has no inverse. Keep that in mind. This part isn't really a question. This is just like a rule that we have to observe, right? And when it comes to finding the determinant of a 3x3, I'm going to ask you to do that once by cofactors and minors. So there will be 1 3x3. And also check this out. I'm going to ask you to find the determinant of a 4x4. Now, when it comes to finding the determinant of a 4x4, that can be sucky and consuming. So guess how the question will be built out?
Zeros.
There will be one column that is almost all zeros. One of the columns or rows will be 0, 0, 0 number. That's the one that you want to use. That's the one that will basically turn the question immediately into a 3x3. If you do it the long way, you will still get the correct answer, but it will take a lot longer. I'm also going to ask you to do one shortcut for a 3x3 and show the work for the shortcut, just because that's a good skill to have. And then when it comes to Kramer's rule, here I'm going to ask you to do this once, and it will be a 3x3. Again, with a fair number of zeros built into it. So there's not very many questions from any given section, just because the few questions that I'm going to ask are time consuming themselves. But this is what Wednesday's chapter test will look like. Yes?
Can you scroll up a little bit, please?
Yeah.
Thank you.
Yep. I know it's a lot of stuff, which is why I'm being extra explicit this time around, just because I want you to know exactly what things I'm going to ask you to do on Wednesday, and know that it's not enough to just have a website where you plug these problems in and it solves it for you, because if that is your technique for this test, you will be unsatisfied with your grade. Make sure that everything here is a thing that you can do by hand, because any one of these questions that I listed out will not necessarily be made of numbers. All it takes is 1 or 2 of the entries to be put in as unsolved variables, and then it becomes a completely different class of question.
Mr. Robbins?
Yep.
Are you gonna put a review for this section? I mean, for these sections?
Yeah, I'm gonna put a review assignment up right now. Yep.
Mr. Robinson?
Yeah.
Is this doable in like the amount of time we have on Wednesday?
Definitely, as long as you are comfortable with this stuff. Most of these are quick. Like I think the determinant of a 2x2 is like quick, as long as you are used to it.
True.
The places where you need to be very efficient with your work, where you need to know what, because it's one of those things where like if you start out and you're not 100% sure what the strategy is, that's where you will lose a ton of time. The ones that may be time consuming are solving by Gaussian elimination. That's why I'm only asking 1 3x3. And then the other place which could be time consuming is finding the inverse by construction. which is again why I'm only asking one 2x2 and one 3x3, but both the 3x3 will have several zeros built into it so that it doesn't take forever. But I assert the rest of these are quick. And all of the ones that are slow, like this is going to require a bunch of determinants. I'm only
Yeah.
asking one, and this is going to have a mess of zeros in it so that these are all quick.
All right.
Yeah. For all the questions that I think would make this test too long to finish in an hour, there will be zeros in there so that you can skip a bunch of the computation and keep rolling. But yeah, if you go into this with no strategy, you'll run out of time.
Mr. Robinson,
Yes.
for solving by Gaussian elimination, you said it's okay if we like do it to like one side of 0 and then solve y by doing Gaussian and then solve for x by plugging it in.
Oh yeah, so that's called solving a system of linear equations by back substitution. So instead of getting your matrix into reduced row echelon form, you get it into row echelon form instead. And then that makes it so that your first equation is x plus y plus z equals number. Your second equation is y plus z equals number. And then your bottom equation is actually z. So then instead to solve for y and x, you take z, plug it into that middle equation, that gives you y. Take y and z, plug it into the top equation, that gives you x. That's what you're asking, right?
Yeah.
Okay, so that would actually be a question here, 9.6, solving by Gaussian elimination. For this question, and I'll be clear about it on the test, you may use back substitution. So if you saw that and you liked it, it's a completely valid approach. It makes it so that instead of doing elimination on 6 digits, you only have to do elimination on 3 digits. If you like that technique here for the 3x3, you may back substitute to get your solution. Is that okay?
Mm-hmm. Thank you.
Mm-hmm. Okay. And I mean, like, you are allowed to have an equation card. I mean, you're at home, so it's open note no matter what I actually say about the test. So like, I would never try to fight that or whatever. And I know it's corny or whatever, but I do recommend using an equation card. Like, I think the simple act of taking the notes that you have and condensing it down into a card, even on an open note test itself, is inherently valuable. It forces you to think about what's important. It forces you to pour through your notes one more time and take notes using your own notes. And on top of that, it just makes it so that instead of wasting time during the actual test being like, oh, where's my notes on this, right? You just have one card ready to go with all the information that you think you'll need to refer to. I had a midterm last Wednesday, and even though it was at home and it was open note, dog, I'm still at home making equation cards for tests. Like, it's a technique that is so valuable that I'm still doing it, even though I turned 30 this year. I'm not going to make it an assignment, but if you're concerned about Wednesday's test and you would like to feel better about it, you want a place to start, I recommend the first thing that you should do today is make an equation card with the important notes and details on it. Use that equation card, like have it in hand while you work on the review. And if it's missing anything, you'll know because you'll find a question on the review that it can't help you with. Figure out how to do that question, update your card. That is it for what is on this test. I'm going to head out. Y'all have a nice day. The chapter review assignment is going to go up right now as I start calculus. And then, like I said, tomorrow when we come in, the warm-up is mandatory. And then you can either hang out and work on the review or sign off afterwards and spend your time tomorrow studying as you will. You all have a nice day, and I'll see you tomorrow.
See you, Mr.
Thank you, Mr. Rob.
You, Mr.